let's build a drone. So we'll start off by building the Quadmula frame, which in this case is the 04 edition. It's a pretty straightforward build. That said, I've added a link for the instructions to the build in the video description. Once I've built the frame, I like to add the motors, install the ESC, and then wire that up first. One thing to note here is the placement of this particular piece I think is incorrect. I also used a different capacitor to the one that was included in the stack, and you might also notice that I oriented the ESC backwards, so that way the XT60 lead could come up through the top plate and closer to the front of the quad. This GEPRC flight controller is a bit odd. It's got an H743 processor, whatever that means. It's got Bluetooth, it has tons of UARTs, but as far as I could tell, it doesn't have any 4v5 pads, and those are the pads that are powered up when you plug the quad into, or the flight controller into USB. So in other words, when you're binding a receiver, and in particular when you're waiting for your GPS to lock satellites, you have to plug in a LiPo, which I'm not a fan of because sometimes there can be the issue of the VTX overheating if you're waiting a while for the GPS to lock. The flight controller has dual gyroscopes, but as it says in the fine print, Betaflight and iNav only support one gyro at a time anyway. If we take a closer look at the flight controller, you can see it's got plugs for a buzzer, analog camera, analog VTX, receiver, and an HD VTX, which could be DJI, Walk Snail, or HD0. The power input for this HD VTX plug can either be VBAT or 12 volts. And there's a solder jumper on the reverse, which you can see here, where you can select that. By default, it's at 12 volts, and that works perfectly fine for the DJI 04 Pro VTX that we're using in this build. For the purpose of this build, we're going to use the ESC, receiver, and HD VTX plug on the top side of the flight controller. And then I'm going to use these solder pads here on the reverse for the GPS. The GPS I'm using doesn't have a magnetometer, so we don't need to bother with the SCL and SDA pads, just the TX and RX. Looking at the receiver, I'm using this dual antenna Radiomaster ELRS receiver. It doesn't come with plugs, so you have to solder the usual RX, TX, 5 volt and ground pads, and just make sure the plugs correspond correctly. 5 volt goes to 5 volt, ground goes to ground, and then remember RX goes to TX and TX goes to RX. Once we've wired up the receiver, it's onto the VTX. Here's the pinout for the 04 air unit. Since we're using a separate receiver, we don't need the last two wires here. So take those out of the 04 wiring harness. Plug one end into the 04 and then the other end into the HD VTX plug on the flight controller. And if we double check, we can see that the 04 end of the harness goes in the order of power, ground, RX1, and TX1. And in the flight controller, it goes power, ground, TX1, RX1. So we're good. And finally, for the GPS, there's no plug. So like I said before, we're flipping the flight controller over and soldering to these pads on the underside. For these here, I used UART 4 and then the 5 volts power. So just to review, we've got the ESC plugged in here, the 04 Air Unit Pro plugged in here, the ELRS receiver plugged in here, and on the flip side we've soldered the GPS right here. I forgot to mention, but it's very important, before you plug in any sort of non-USB power supply, that's both at this step and also the earlier step when I had just the ESC wired up, please make sure you use a smoke stopper. Of course, that's just one part, so now let's configure everything in Betaflight, which is pretty straightforward. At the time of making this video, it's September 2025, so I've got Betaflight 4.51 running on this one. Plug in the quad via USB, hit connect, and then we've got the setup screen initially, but we'll skip this one for now and go to the config tab. This flight controller should be easily able to run a 8K PID loop, so I've changed that. The accelerator toggle should already be on, but this FC also has a barometer, so let's toggle that on as well. Down here, make sure air mode and GPS are toggled. Also, right above it, change the maximum arming angle to 180 degrees. In the board and sensor alignment heading, under the gyro accelerated setting, selecting the first gyro uses the MPU 6000, and then the second one is the ICM blah 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 gyro. I just kept it on the first. And don't forget, we have to adjust the board alignment. We have to do this because remember, I just wanted to be different, and I put the flight controller backwards. So change the yaw alignment to 180 degrees to reflect this rotation. Hit save and reboot. So let's hit connect again, and we're at the setup tab. Here, click calibrate after you've put the quad on a flat surface and give it a second. Now, if you move the quad around on the bench, the movements on screen and the ones that you're doing in real life should correlate with each other. Now go to the ports tab. Make sure UART1 is turned on and go to the corresponding peripheral option and select VTX with MSP plus DisplayPort. UART2 is our receiver, so toggle the serial RX setting for that. UART3 for this particular flight controller is Bluetooth, so the config/MSP for this UART should be toggled to on. And since we chose to connect the GPS to UART4, go to that column, but for the GPS we don't have to turn on serial RX or the config/MSP. Just go to the sensor input and toggle that to GPS. This particular GPS has a baud rate of 11520, so select that, but it might be different depending on whatever setup you're using. So just to review, for this build we've got the O4 Pro on UART1, the receiver on UART2, Bluetooth on UART3, and the GPS on UART4. At this point, you could bind your O4 unit to the goggles, which requires you to plug in a LiPo. Once linked, you should be able to see the video and the OSD on your goggles if you set that up. You can play around with the presets tab here, but make sure you make up a backup before doing anything crazy. Usually I just use the ELRS RC link preset that corresponds to the frequency I'm using. Go to the receiver tab and make sure CSRF is selected here. Depending on what transmitter/remote control you're using, you may have to select the TAER1234 profile here. Assuming you've already bound your receiver, once you hit save or reboot, you should check that the outputs on the left change according to what you're doing with your transmitter. On the majority of new flight controllers, there'd be at least one 4v5 that's USB powered pad that could run power. And if you've connected your receiver to the pad, you could test this out right now just with the flight controller plugged into the USB. However, since I couldn't find one of those pads on this flight controller, I had to plug in a LiPo. Similarly, when we go to the GPS tab, you notice that the GPS icon is completely blank. And it's completely blank because the GPS isn't receiving any power. So again, plug in a LiPo and you'll see that this icon should light up. And you should notice that as long as you're close to a window, the GPS will start to find satellites. For the GPS settings, turn on U-blocks, auto config. I put set home point once, and then the ground assistance to auto detect. For both the GPS and receiver setup, depending on how long this process takes, you might want to have a small fan on your workbench to prevent the O4 Pro overheating. If we want to use the GPS rescue, we need to go to the failsafe tab, Configuring this is worth its own video, and there's many really good videos out there by much better creators. However, these are the settings I use, and you could pause the video and copy them if you want. We're almost done, so let's go to the motors tab. iFly props out, so change that, hit save and reboot. Because the ESC is also backwards or reverse, we need to change the motor mapping. With the newest versions of Betaflights, it's easy peasy. Just hit reorder motors and follow the prompts. You have to have your quad powered up for this, and please don't forget props off, or something like this could happen. After reordering the motors, use the direction wizard to make sure everything's spinning the right way. This ESC, even though it's a BHEL-LES ESC, comes flashed with the ability to use bidirectional DSOT, so you can turn that on. The motors in this build are like most 5-inch appropriate motors, and they have 14 motor poles. If you're using smaller motor poles, then you might want to double check this, as sometimes the smaller motors have 12 motor poles. Final steps are the receiver tab. I strongly suggest you use a pre-arm switch to avoid accidentally getting your finger sliced. Set up the OSD however you want, do a little test hover, and now it's time to fly. This first clip is from my Maiden flight, and before doing any form of PID or filter tuning, so this is an untuned flight. I think this combo of frame and motors flies great. It's super smooth, it's super responsive, and even though technically there's props and views, when you stabilize the footage, the props are almost invisible. And also, the O4 Pro is phenomenal, and it's the first time for me that I can say I don't need a GoPro. I thought the DJI-R3 was great and the footage was very good, but I still felt like a dedicated action camera gave better quality footage. With the O4 Pro though, it's practically on par with an action camera, and then you save the weight of that too. My gripe with this build still remains the flight controller and the lack of a 4v5 USB powered pad. It's mostly just a pain during setup, and these M10 GPSs lock satellites pretty quickly, but I still don't like standing around with my quad plugged in and potentially overheating while waiting to get a lock. Anyway, hope you enjoyed the video. I kept the music to a minimum this time, and I got a mic! If you made it this far, I really appreciate you. Please like and subscribe to this video if you can, and I hope you have fun flying. Thanks a lot.